To verify an identity, the idea is to take one side and transform it so it looks like the other. So a couple of strategies would be like, well, maybe starting with a more complicated side is better because you'll have more to work with. So I see we have cosine times tangent is equal to sine. So I think a good strategy for this problem would be replace tangent so it's written in terms of sines and cosine. So as my first step on the left side, I'm going to leave cosine of x alone, but tangent is defined as sine divided by cosine. And we're really asking, is this in fact equal to sine? And I can really see that after one step, if I want to multiply these two fractions together, I have a cosine in both the numerator and the denominator, and so they cancel. And this leaves us with sine of x on the left and sine of x on the right. And once the left side is equal to the right side, we have verified the identity. So again, a strategy would be take a more complicated side, simplify it to make it look like the other side. And you can use identities to do that, or definitions, and that's the general process. So for this problem, to verify this identity, I'm definitely going to take the left side because it's more complicated and try to make it look like the right side. And there's a few notes I'm going to make off to the side. First, what is the definition of cosecant of x? This is defined as 1 over sine of x. Something else I'm noticing is this cosine squared of x. There's a fundamental identity, which is that if you take sine squared and you add it to cosine squared, this is equal to 1. So with these couple of notes, I'm going to now try to simplify the left side of this equation. And, we could start by replacing the cosecant with 1 over sine, but I think as my first step, it's a common factor that I can remove from both terms. So working with the left side of this equation, if you factor out cosecant of x, what is left over is 1, and then minus and cosine squared of x. We're asking, is this thing going to equal sine of x? Is this true? Written this way, we could replace cosecant with its definition of 1 over sine. So I think I will actually place that into the next step. So far, all of our lines are equivalent. And I'm seeing we have this 1 minus cosine squared. The reason I wrote this identity down is because if you subtract cosine squared to the other side of this equation, you'll have 1 minus cosine squared, which is exactly what is sitting right here. And that leaves sine squared of x on this side of the equation. So said another way, if you see a 1 minus cosine squared, you can replace it with simply sine squared of x. So I'm going to make that substitution. All right, so we're getting really close to where I think the left side will simplify to the right side. We don't really need these parentheses anymore. In fact, if we want to multiply this to this, we can put this as divided by 1. And what we have is 1 over sine of x times sine squared of x over 1. Is that equal to sine of x? And the answer is yes. You can cancel this sine of x into one of the two that are within the numerator. And so what we have left over is, on the left side, just sine of x, and that is certainly equal to sine of x on the right. So it's like no longer a question. This is certainly a true statement. All of the previous lines are also equivalent, meaning we have verified this identity. All right, so let's verify this identity. When deciding which side is more complicated, they both are fairly complicated. I'm seeing a difference of two pieces, so I'm going to start by working with the left side. You could try this by doing the right side. There's nothing wrong with that, but I'm just thinking I'll try this way. Okay, I see I have secant of theta. So just again, a kind of a note to myself here. The definition of secant is 1 over cosine. So I think the most logical place to start is to take the left side and replace secant with its definition, 1 over cosine. And hopefully this will somehow simplify to the right side, sine of theta times tangent of theta, so the negative of that. So we have to have a direction to go over here, and, well, maybe we could combine these things into one fraction by getting a common denominator. So my common denominator would have to be cosine of theta. Basically, I'm going to take this fraction and I'm going to multiply the top and the bottom by cosine of theta. In the top, we'll get cosine squared. In the bottom, we'll have cosine. So for the next line, if we want a common denominator, we're going to use cosine. And since it is now common with cosine of theta in the denominator, this is cosine squared theta minus 1 all over cosine of theta. And somehow this should simplify to negative sine theta tangent of theta. So kind of like in the previous question, I have cosine squared theta minus 1, and what we saw last time was 1 minus cosine squared of theta was equal to sine squared of theta. So like this is really close to this. The difference is it's off by a negative. The 1 is negative and the cosine squared is positive. That means we're multiplying this side by negative 1. So that is, it's really negative 1 plus cosine squared of theta. But that means you're multiplying the other side by a negative as well. So this cosine squared theta minus 1 is really this. And it's not equal to sine squared theta, it's equal to negative sine squared theta. I'm going to replace this with negative sine squared theta. And we're starting to get really close to completing this question. Well, the good news is I want a negative sign, and I have a negative sign, and there's actually 2 of them, but somehow I want to get tangent of theta out of this. So maybe just as a reminder, well, I know tangent of theta is equal to sine over cosine. So now I have an idea of where to go. I'm going to take the left side and write it as negative sine of theta, and then I'm going to break it apart so I don't have sine squared of theta, but so it's written like this. So sine squared is equivalent to this part here. And sine over cosine is tangent. So, I mean, at this point, we have our negative sine of theta. Sine over cosine is tangent of theta. And we made the left side look like the right side. This verifies the identity. So just as some final thoughts, when proving identities, some facts that will take you a long way are basic definitions for the main trig functions. So like if you see a tangent or cosecant in your expression, well, maybe you could replace it to something in terms of sine and cosine. That might give you a direction to go in. 3 other important identities that will show up are these here. That is, sine squared plus cosine squared is equal to 1. And there's 2 equivalent forms. So that's 1 plus cotangent squared is equal to cosecant, and tangent squared plus 1 is secant squared. So if you're stuck in a problem, see if like you have things like this, sine squared or cotangent squared, appearing within your expression.